We are going to talk about our machine learning project, which is the recommendation system on movie. We choose two different methods, SVD and CNN, to realize the system and try to find out the different performance by using them and then give a conclusion. First, let me introduce the background of our project. Nowadays, people used to buy or choose products online more than from stores. Previously, people used to choose something based on the reviews given by relatives or friends, but now, as the options increased and we can buy anything digitally, we need to assure people that the product is good and they will like it. To give confidence in this, recommendation system was built. As one of the hardest decisions, movie recommendation is really a complex but interesting matter. It should store people's interests, age, occupation, gender, and so on. And then, according to some information, like ratings on movies, collected from people who have different attributes above, we can make a series of computation to get a model or a set of data that would indicate what kind of people may like some type of movies. And finally, give the person who wants to have a recommendation a satisfied result. Then our goals. Our goal is to dig into the pros and cons between the recommendation systems using user-based collaborative filtering and content-based filtering. In other words, use SVD and CNN. We may have to know some basic knowledge about them. First, SVD, the singular value decomposition, or SVD for short, is a matrix decomposition method for reducing a matrix to its constituent part in order to make certain subsequent metric calculations simpler. It says that any matrix A can be factorized as A equal U S transpose V. Using SVD, we can go from n features to k features, where each one will be a linear combination of the original n, which is called k-truncate SVD, and is really useful for getting rid of the redundant data. Next, the CNN. We don't need much words on CNN, as we had learned it in lectures, but we should remember that the core ideas of a CNN is local receptive fields, shared weights, and pooling. In our experiment, we use the dataset movie length, which is collected by the group length research. These datasets were collected over various periods of time, depending on the size of the site. We use the 1 million site for CNN method and a small set for SVD. The 1 million dataset contains 1 million ratings from 6,000 users on 4,000 movies, and small one contains 1 million ratings on 9,000 movies from 600 users. There are three files in it: users, movies, and ratings, and they have similar format. Users have user ID, gender, age, occupation, and zip code fields, which age is using the 7 number to represent the age range, and the occupation is chosen from the 0 to 20, which is also a meaning of different fields. Zip code is not used. Movie has movie ID, title, and their genres fields. Some movies may have more than one genre. Rating has the user ID, movie ID, rating, and timestamps. Ratings are made on a 5-star scale.
As we mentioned before, the most common and simplest way to implement a recommendation system is the traditional SVD method, singular value decomposition. Let me introduce the data preparation first. We use the ML latest small dataset from movie length. It describes 5-star rating and free text targeting activities. There are 100,836 ratings and 3,683 target applications across 9,742 movies. We only used 2 CSV files among the whole 4 CSV files in the data set. They are ratings.csv and movies.csv. Then we filter 3 features in the movies.csv, movies row, movie ID, and the title. Because in our model, we assumed that the movie features are hidden in the rating activities instead of the content in the dataset. Then we replace movie ID in ratings.csv with row number because the movie's ID is much longer than the row ID. After that, we generate 2 matrix rating and recording. In modeling, we normalize rating matrix and rating record matrix. Then we assume that the movie has 10 hidden features. Next, the user item rating matrix is decomposed into an X matrix and a theta matrix. Of course, the calculation of the matrix needs to be modified during the iteration process. In one iteration, we calculate the loss of the matrix by tens floors minimize. After calculate gradients, we update the value. During the train process, the following 2 pictures correspond to train loss and test loss. After training, we calculate means. After training, we also calculate mean squared error to verify the results. The MSE is about 0.67. It looks pretty good. Then let me demonstrate this whole movie recommendation system, putting user ID and predict the user's rating of all movies. Select the top key with the highest rating and then show the result.
The next method is CNN for recommendation system. As we mentioned, CNN has made great achievement in image identification. And in the field of text processing, CNN based on text mining is proved to be effective. We can use the raw vector as a token, including words or characters. And a piece of text has n words, and each word has an m-dimensional words vector. We can construct n by m matrix to do neutral language process. So let's practice with CNN. This is our data set, 100 million ratings for 6,000 users to 4,000 movies. This is about processing the data. We keep the user ID, occupation, movie ID item, and use number to replace the gender and the age. The movie type and title convert to a number in a dictionary, and the length should be unified. In the feature extraction, in the category variables can use one-hot encoding, but for user ID, movie ID, it will cause high-dimensional and sparse problem. So we use embedding layer to do feature extraction. For user feature, we use user embedding layer as the index of the embedding layer matrix. And through two fully connected layers, the output of user feature matrix is n by 200 matrix. In this way, the final output of user feature dimension is relatively high, which ensures that the feature of each user can be fully carried and expressed. For movie feature, it's about movie ID and movie types. Do the same thing as user embedding layers. Especially for the movie types, a movie has more than one type. So we do matrix sum for movie types so that the movie type information will not be lost. For the movie title, the text convolutional neural network is a little different from the CNN because we process natural language, which is usually a piece of text. There will be multiple filters of different size operate sequentially, and the filter wells will be the same as the wells of the matrix, sliding the whole line. We can see our process as below. The input is 32 by 32 matrix, and through 4 filters to do the convolution and the maximum pooling, and then drop out operation through the fully connected layer. Finally, the output is a 1 by 32 matrix. This is our model based on CNN. After training user future and movie future, we can feed readings. There are two methods. The first one is vector multiplication of two features, regression between the result and the real readings. The second one is take the two features as input. Through fully connected layer again, return the output value to the real readings, and MSE was used to optimize the loss. In the training process, parameters should be adjusted. After 10 times, we find when batch size equals 512, loss will fluctuate. And we decrease learning rate, loss decreased. But when learning rate decreased too small, the loss increased. So based on this, we fix the parameters as below. And we do the course validation. The dataset is divided into training set and the test set according to the ratio of 4:1. After that, we can visualize the training loss and test loss. We can see the decreased trend of test set. After the model training and verification, the movie recommendation is actually carried out. Use the user feature matrix and the movie feature matrix to recommend. There are many 3 ways to recommend movies. First one is the same type movie recommendation. The cosine similarity between the movie eigenvector and the whole movie feature matrix, and select top K with the largest similarity and add some random selection. The second one is recommend your favorite movie. Calculate the rating of all movies by user eigenvector and movie feature matrix, and select top K with highest rating. It also needs to add some random selection. And the third one is after one user watched a movie, recommend other movies. First is select top K users who like the certain movie, and get the user eigenvector of these people. After calculate the rating for all movies, finally choose the movie with the highest rating for recommendation. It also needs to add some random selection to make sure each recommendation is slightly different. So this is our result with CNN Math in recommendation system.
SVD-based collaborative filtering is the most widely used recommendation algorithm at present, but there are also serious data sparsity and code start problems. In addition, the classic collaborative filtering method cannot learn the deep features of users and items by using shallow model. It needs effective feature extraction, and this kind of SVD-based collaborative filtering traditional shallow model relies on artificial design features, and its effectiveness and scalability are very limited, which restricts the performance of recommendation methods. The recommendation system based on deep learning can use deep learning technology to integrate various types of heterogeneous data, automatically learn the hidden features of users and items abstractions, and model the sequence pattern of user behavior, which can more effectively reflect the different preferences of users and improve the accuracy of recommendation. As for the conclusion, we find that most of the deep learning methods, such as CNN, are enhancing the collaborative filtering method, and it has a great improvement compared with the metric decomposition methods, such as SVD. And because the entertainment industry data set is rich, the effect is convenient to verify, making most of the deep learning methods for the entertainment industry, such as music and film recommendation, have a better effect than the traditional recommendation system.